Welcome to the Citrus Mechanical Harvesting website video collection. The goal of citrus mechanical harvesting is to reduce net harvesting cost while at the same time increasing labor productivity. Several growers utilizing mechanical harvesting are reporting between 25 to 35 cents a box savings, suggesting there is a promise for real harvest cost savings. In the 2006-2007 season, there were more than 35,000 acres mechanically harvested. The trunk shake and catch system is one of the three systems that are making commercial headway into mechanical harvesting. To help you understand about the trunk shake and catch system a little before you watch the video, let me explain the system units. A trunk shake and catch system includes three machines: a shaker, a receiver, and a field truck commonly referred to as a goat. One system requires two machine drivers and one goat driver. Typically, a goat driver will service two systems. The shaker, which must be driven in the swale side of the row, extends a wheel to stabilize the machine. The driver then positions the machine to grasp the trunk with a rubber-covered clamp shaking the tree, which causes the fruit to fall from the canopy. The receiver, which must be driven on the bed side of the row, works opposite of the shaker, extending a catch frame up under the tree to catch the fruit being removed by the shaking action. The frame is positioned close to the shaker to prevent fruit from falling through the gap of the catch frames. This fruit is then transported up by a conveyor belt to an elevator system. Most of the leaf and stick trash that falls onto the frame with the fruit is removed by a series of blowers and brushes as the fruit is conveyed to the cart. The cart, which is being pulled by the receiver, catches the fruit being conveyed by the receiver. These carts hold between 70 and 90 boxes of fruit. The cart can be lifted to allow fruit to be dumped into the goat. The goat, which is fabricated from a skeletal truck body, transports the fruit from the cart to the trailer for transport to the juice plant. It also has the capability of the bed being lifted and the fruit falls into the trailer. Let's hear and watch the machine in action. The shaker, which must be driven in the swale side of the row, extends a wheel to stabilize the machine. The driver then positions the machine to grasp the trunk with a rubber-covered clamp shaking the tree, which causes the fruit to fall from the canopy. As you watch the tree being shaken, note that the receiver is catching and conveying the fruit into the cart. Trees must be skirted between 18 to 30 inches at the drip line for the catch frame to efficiently work under the tree canopy. Here you can see the shaker and receiver units working side by side. Note the shaker on the right has its catch frame above the receiver catch frame. A good seal between the two units at the base of the tree minimizes the amount of harvested fruit escaping to the ground. You will also notice how the fruit falls onto both sides, being deflected by the shaker frame, then falling onto the receiver side. The trunk is being shaken in a linear pattern. On occasion, sections of the trunk bark can be stripped away. This, along with other signs of visual damage, have not, however, been observed to cause increases in tree mortality or yield losses. The receiver unit will typically clear off the conveyor belt before leaving the end of a row. Here you can get a better look at the trunk and skirt height requirements and why they are needed. Note how the fruit moves up the conveyor belt to be emptied into the cart being pulled behind the unit. You will see pieces of branches and leaves mixed in with the fruit. Most of this woody trash is being removed by blowers and brushes positioned along the elevator belt. The goat driver will back up to the end of the cart. The cart bed rises up and tips, allowing fruit to run into the back of the goat. He will then maneuver the goat back and forth to allow for even distribution of the fruit in the bed of the goat. If tree yields are less than 3 boxes per tree, one goat operator can service 2 machine sets. The goat driver raises the bed to allow fruit to be dumped into the trailer. From here, the trailer will be taken to a designated juice processing plant. From numerous field observations of the trunk shake and catch system, the following performance statistics have been compiled. These statistics represent average growth conditions in southwest Florida, since most of the mechanical harvesting between 1999 and 2003 was done in the southwest region. Fruit removal averaged 95% for shake durations between 5 and 10 seconds. Fruit recovery refers to the percentage of fruit on the tree prior to harvest that is delivered to the bulk trailer. When the system components and operators are working smoothly, a trunk shake and catch system can consistently harvest 3 trees per minute. Runtime, or the active harvest period after allowing for row turns, routine maintenance during the day, and fruit transfers from cart to goat, averages around 60%. Assuming trees yield 3 boxes per tree and factoring together recovery percentage, harvest speed, and runtime, a 3-person trunk shake and catch crew can harvest approximately 300 boxes per hour. This is a 10-fold increase in harvest labor productivity over hand harvesters. There are several issues that must be addressed to assure success when using mechanical harvesting. Improving the mechanical efficiency and lowering harvest cost will take a combined industry effort. The grower will be responsible for properly preparing the trees. The equipment manufacturers and operators will need to work toward improving the fruit recovery percentages. The processors need to allocate sufficient trailers to allow efficient equipment use. And finally, research is needed to develop an effective abscission agent that will allow mechanical harvesting to continue through the Valencia harvest period. Success of any mechanical harvesting system will be measured by its ability to reduce net harvesting costs below what is being paid currently to hand harvesters. By net, one must factor in costs of pruning, skirting, and other steps in growth preparation, as well as the value of any non-harvested fruit. Gleaning cost must be considered as well if fruit prices justify harvesting the 8 to 10% of the crop that a mechanical harvesting system will not recover. Until there is an effective abscission agent, mechanical harvesting may be shut down once the diameter of the emerging Valencia fruitlets exceed 1 inch. In most years, this point will occur around mid-May. Shaking late-season Valencias without abscission can cause next year's yields to decline by more than 25%. All growers should assess the economic implications of a specific mechanical harvesting system in their growth. A web-based model is available at citrustool.ifas.ufl.edu. It allows a user to input their specific grove and harvest cost information to see if there is a financial advantage from using a mechanical harvesting system. For further information about trunk shakers or other mechanical harvesting systems, visit our website at citrusmh.ifas.ufl.edu. Please visit our website and use the contact information for further information. Thank you for viewing our video collection.